These are our sum and our difference identities. I forgot to record while I was writing these down. So if you just need to pause the screen, I'm telling this to the people that are listening on YouTube. So if you need to pause the screen, you can pause it and write those down.
Like and subscribe.
Like and subscribe. And ring the bell in the corner. Ding.
Not the notification bell.
Notification bell. Some random people were commenting on my videos for y'all's class. So I was like, I took the comments off. Okay, did we get all these written down? Almost, okay. So what we're going to do now is we are going to kind of work backwards with this next set of problems. They're going to give us the formula part already worked out. And what we want to figure out, is it a sine, cosine, or tangent formula? And is it a plus or a minus? And then that's going to lead us to like our original part. It's like they already did all of the steps, and we have to figure out what they used. So in our first one, is this a sine, cosine, or a tangent formula? Y'all can just mouth it. It's tangent, right? And let's look at the signs. Is it going to be the plus one or the minus one?
The plus.
It's the plus one, right? So what I'm going to do is I notice that it's tangent, and I notice that we had a plus here and a minus here, so that's going to be our top one. So I'm going to write that this is tangent of, and then I'm just going to say what my x and my y were. So my x was 4 theta, right, plus, and my y was negative 3 theta. You guys see what I did? Found out that it was tangent and that it was plus, and then just identified these two things, this one and this one. And now I'm going to combine like terms. What's 4 theta plus negative 3 theta? That makes how many thetas? 1. Yep. So our answer is just tangent of theta.
So the bottom's just there.
This one? This one, this bottom here?
Yeah.
It's part of the formula. So you would have needed to have that part of it here.
So you're saying we needed to know the formula, but we're not going to do nothing with it?
They already filled it out for you. It's like going backwards. If we were in this part, we would have plugged it all in here, but they gave us what was already filled out, and we had to figure out what they started with. All right, let's look at
we're pretty much factoring.
No, you're not factoring. You're just seeing which formula they used.
I was talking about like where you have to work backwards and stuff, like to get to that. Yeah, they're right there.
Yeah, here. Oh no, we're not factoring it. We're looking and saying that was a tangent formula. It was tangent of x plus y. The x was the 4 theta. The y was the negative 3 theta. Because that's where x and y are. So we just used it and plugged it in here. We just plugged it in the tangent of whatever this was plus whatever that was.
And you did 4 minus 3, correct?
Yeah.
Okay.
All right, let's look at the second one. Is that a sine, cosine, or tangent equation? Look at how it's lined up.
Sine.
It's a sine equation, right? Because it goes sine, cosine, cosine, sine. So those are the kind that do that. So we know it's a sine equation. Is it a plus or a minus?
Minus, ain't it?
Yeah, look for the sine one. You see when there is a minus here, that goes to the sine x minus y formula. Okay. So our x was 2u, our y was 3u, and this was a minus formula.
-1.
Yep. So sine is negative 1u, or just negative u, or sine of negative u. Sorry. Okay, let's try the last one here on this simplifying kind. I've got cosine, cosine plus sine, sine. Is that sine or cosine?
Cosine.
That's cosine. And it was plus here, which makes it the minus formula. So this is the cosine minus formula. So cosine 2v minus negative 6v.
8v.
Yep. Thumbs up if we're okay with that. Just matching the formula, then figuring out what the u and the v are. Okay. The next
Okay,
thing.
so I have a question.
Mm-hmm.
You know how, okay, look at number 2, it says sine 2 cos 3 minus.
Mm-hmm.
But you looked at the left side to figure out if it was a minus or a plus. Why wouldn't we just use the minus that was in the equation?
We used this to figure out if it was a minus or a plus. So I used that minus, and that matched with this one. On this one, we used this plus in the middle and matched it with this equation. That
So why do we use the minus though?
Because for cosine, in the cosine formula, for the cosine subtraction formula, x minus y, there's a plus in the equation. It's backwards with cosine.
Okay.
So there's a plus in the equation that goes with a negative for the cosine.
Okay, thank you.
Mm-hmm. The next kind are the same, except that they're actual numbers. And once you get the actual number, it'll be like cosine of 45 degrees or cosine of something. Then you look at the unit circle to figure out what your answer is. So let's look at 17. Well, I said 17 because it's in the problem. It's actually number 4. Is this a cosine formula or a sine formula? Cosine formula. And we had a plus there. And remember with cosine, if there's a plus, we're going to use subtraction. So cosine of 197 minus 17. And 197 minus 17 is 180. Everybody agree? Okay. And then we look at our unit circle and think about what cosine of 180 degrees is. 180 degrees, cosine is the x value, so that is negative 1. Mm-hmm. So when they say find the exact value, you figure out which equation they were using. And then once you get the degree or radian, if you're using radians, then you'll look at your unit circle. So that equals negative 1. Right, on number 5, is this a sine, cosine, or tangent formula? It's tangent. Is it a plus or a minus? It's a minus, okay. So we got tangent of 4 pi over 9 minus 7 pi over 36. Let's work that out to the side. We have to have a common denominator, don't we? I can make this denominator 36, can I? Guess I'll just write it next to it. So what do I need to multiply on top and bottom to make that 36? A 4. And it'll work. Okay. So tangent of 16 pi over 36 minus 7 pi over 36.
Can you slow down? I didn't get to write the problem down.
Okay. So go ahead and subtract 16 and 7, and that's going to be 9 pi over 36. And we simplify that. 9 over 36 is a fourth, right? 1/4. So we're looking for tangent of pi over 4.
Why did you use pi instead of 1?
Because there's a pi in the problem.
Oh,
With it
okay.
the whole time, yeah. So we have to keep that pi with it.
Can you explain what you did? Because, like, I don't understand
Which part? The getting the blue part or the green part?
the green part.
Well, we had two different types of fractions. This one had a 36 on the bottom, and that one had a 9. So I need a common denominator. Like if I was doing 5 over 7 plus 3 over 14, I can't add those like they are. I need to have the same denominator. So I could change them both into 14s. So I would do a 2 on top and bottom. And that would be 10 over 14 plus 13 over 14. Now you can add them together.
Okay.
Same thing here, except I just had pies with it. So I needed a 4, and I could turn that into a 36, and they'd match. So I just multiplied by 4 to get 16, and by 4 to get 36. Then that made 9 over 36, which simplifies to a 4th. And tangent of pi over 4, that's one of the ones we do all the time. That's our y over x. They're the exact same thing. So when you divide them, what's your number going to be? 1, right? All the tangent of pi over 4s or 3 pi or 5 pi or whatever, they're all going to be a 1 or a negative 1. If they go ahead and give you the formula, you're just figuring out, is it sine, cosine, tangent? Is it plus or minus? Once you get the number, then you can do that. If you don't like to have to deal with radians and doing all the fractions, you could turn these into degrees at the beginning if you wanted to. Just remember to plug in 180 for pi, and you could have both of those in degrees, and you don't have to worry about radians. That's what I'm going to do on number 7. All right, on number 6, they want us to figure out what sine of 75 is. Is 75 a number that's on our unit circle?
No.
No, 75 degrees is not on our unit circle. So if you get a number that's not on the unit circle, you are going to make a sum or a difference, find 2 angles that either add up or subtract to that number. So do we have 2 angles on here that would add up to 75? Yes.
45.
45. Okay. So what we're going to do is we're going to write it out as a sum of 2 numbers that are from our unit circle, and then we'll use one of our equations from the top. So we decided to do 30 and 45, right? So we're going to look for sine of 30 degrees plus 45 degrees. And remember, we can't just do sine of 30 plus sine of 45. If you have a sum or a difference, we have to use one of our formulas from up above. So we're going to use the sine plus formula. Okay. So the first variable we're going to use is the 30 degrees. The second one would be the 45. So this would be like our u or our x. Am I saying u's and v's? And there's a lot of x's and y's. Sometimes people use u's and v's. So this will be like our x. This will be like our y. So our sine formula, just as a reminder, is sine cosine plus cosine sine. So sine 30 degrees, cosine 45 degrees, plus cosine 30 degrees, sine 45 degrees. Everybody follow that? We didn't have the number on the unit circle. We split it up so that we would have 2 numbers from the unit circle. We figured out what equation to use. And now we're just going to write down all of these answers from the unit circle of 4 of them, and we simplify it, and we'll have the exact value of sine of 75 degrees. So we need sine of 30, cosine of 45, cosine of 30, and sine of 45. What is sine of 30? Sine of 30 is a half, right? Okay. So sine of 30 is 1/2. Cosine of 45 is root 2 over 2. We know that one. Cosine of 30 is root 3 over 2. And sine of 45 is root 2 over 2. So I just wrote down what all of those were. We okay with that step using the unit circle? Yes, no, nobody moved. Writing that down. Okay. Now we're just going to multiply the things that need to be multiplied together. That's going to be root 2 over 4 plus root 6 over 4. So our answer would be root 2 plus root 6 over 4. We find the two things, use the formula, write the numbers from the unit circle, and then multiply them that we need to.
Seems pretty simple. How many more questions are there?
65. No, we have double angles to do. We're almost, well, we have like 4 questions with the double angles. These are the sum and difference ones. And one more type of identity today after this one question. All right, our next one, we've got tangent of negative 5 pi over 12. I don't like to use radians when I'm trying to figure out two things that add together to get something. I would rather use degrees. So if we go ahead and switch this to degrees, remember we can plug in 180 into pi, just a reminder in case you forgot that. So we end up with negative 75 degrees.
Okay, how did you get the negative 75? I'm sorry.
I'll put 180 in for pi. 5 times 180 divided by 12. Anytime you want to go from radians to degrees, you can just substitute 180 for pi because they're the same thing. All right, now we're going to look on our unit circle and find a way to get negative 75. Probably some subtraction is going to have to go on, won't it? Do y'all want to do some negative angles? We could make negative 75. That would be a little bit easier than trying to think about something that's 75 more than something else. I guess we could do this. This is 45, and we could do 150 minus 225. That makes 75, doesn't it? Y'all want to do that? Doesn't really matter. That one works, though. You could have done negative 30 plus negative 45 as well. Okay, now I'm going to use the tangent formula. We use the plus or the minus. The minus, we're going to do tangent and the minus formula. So that's tangent 150 degrees minus tangent 225 degrees over 1 plus tangent 150 degrees times tangent of 225. So I just plugged it into the tangent subtraction formula from above that you wrote at the top. First, Angle measure is here and here. Second one is there and there. So now we just need to know what tangent of 150 and tangent of 225 are, and we can plug them in. So we'll go to our unit circle. Tangent's better because you only have to do 2 things. On all the other ones, you have to do 4. You have to do the sine and cosine of both, and on these, you just have to do the tangent of both of them. Tangent of 150, that's y over x, right? So that's 1 over negative root 3. We need to rationalize. So that would be negative root 3 over 3. Okay, so that's the tangent of 150. The tangent of 225, these are both the same, so it's going to be 1, right? And they're both negative, and negative over negative makes a positive 1. So the tangent of 225 is 1. The tangent of 150 is negative root 3 over 3. So we plug that in.
How did you get that?
Get what part?
The 1 over negative root 3.
Tangent is y over x, and the y was 1/2. And x is negative root 3 over 2. When you divide fractions with the same denominator, they cancel out. So I just have 1 over negative root 3 here.
Oh, okay.
And you can't use your root, leave your root 3 on the bottom, so you have to rationalize it. Okay, and then in CUDA, because you know how they always simplify everything as much as possible, they would find common denominators with all of the stuff and cancel, and some things are going to happen. But what I want you guys to do, instead of spending the time doing that, because that doesn't really, there's really no benefit for it, you're going to have a couple different answer choices. Like put this answer in the calculator and get whatever the decimal is, and then see which one in CUDA matches that. Does that make sense? Okay. Because I could show you how to simplify, like you would need a 3 over a 3 here, a 3 over a 3 here, and 3's will cancel, and then that'll be negative root 3 minus 3, and that would be 1 plus negative root 3, and then something else messes up. But y'all could just type that in the calculator and get your decimal, make it match with the options you have. Okay, for those? All right. And for any short answer on the test, I'll accept this. That's as far as I need you guys to go on the tangent ones. Got that written down. The next ones are our double angle identities. Our double angle identities are just kind of an extension of what we just did, but instead of having 2 separate angles, like an x and a y, they're both going to be the exact same. So it's like thinking you have an x plus an x. So we're going to use the same formulas, except we'll have an x and an x instead of an x and a y, and it's going to make it easy for us to do some substitution. So I'll just show you real quick on here. If these were both x's, if I had sine x, cosine x, sine x, these two end up being the same thing. They're both sine x, cosine x. So when you add them together, there's just going to be 2 of those, and it makes the equation more simple. So if we are thinking about double angles, like sine of 2x or 2 theta, you can see it either way. That is simply 2 sine x cosine x.
Yeah, you off mute.
Okay, good. So that's our first double angle identity, sine 2x. If we see a sine 2x, we can replace it with 2 sine x cosine x, and that's going to help us simplify some of our problems. But that came from the equations that we just did in our formulas there. Okay.
So these are different identities?
Yeah, these are called the double angle identities. They're really just like an extension of the other one. We use them so much that instead of plugging in x and x every time, We just think of having 2x there. Right. Now cosine of 2x, if you go to your cosine formulas, and these were all x's instead of y's, I'd have cosine x times cosine x, which makes cosine squared, sine x and sine x, which makes sine squared. So our double angle for cosine is cosine squared x minus sine squared x. And our cosine formulas get modified some because we can plug in our Pythagorean identities. Remember, for cosine, that was 1 minus sine squared, and sine squared was 1 minus cosine squared, and we did that. So if those get plugged in, you could also rewrite these in this way. So cosine 2x is also sometimes the same, written the same as 1 minus 2 sine 2x, or 2 cosine squared x minus 1. So cosine 2x can be replaced with any of these three things. It just depends on what's more beneficial in your equation. Then the last one is tangent. Think about if that y in your tangent plus formula was turned into an x. If you had an x and an x, you would have 2 tangent x's on the top, and then 1 minus tangent squared x, because those 2 tangents that are multiplied, they're the exact same, so it would be squared. So these are our 3 double angle identities. We have 2 types of problems that we'll use these for. The first one, they're giving us one of our trig functions and they want us to find a double angle. So we're going to have to do some substitution. And the second kind are equations where we can't solve them with a 2 theta in there. We have to replace it with one of our identities, just like we did with the Pythagorean ones last time. Probably not as much factoring though. Okay. So on our first one, they tell us that cosine is 3 over 5, and they say we're between 270 degrees and 360 degrees. Every time they tell you what quadrant you're in, it's just so you know if your trig functions are positive or negative. So if they tell you that, think, oh, I better think about positive and negative. Otherwise, they wouldn't let me know. They wouldn't be specific there. What quadrant are we in if we're between 270 and 360? I'm going to just hold your fingers up. Between 270 degrees and 360 is what quadrant? The 4th, yeah. So we are in quadrant 4. And in quadrant 4, it goes ASTC, so cosine is the one that is positive. Everything else is negative, right? Okay. So they tell us cosine is 3 over 5. They want us to find cosine of 2 theta. But to find cosine of 2 theta, I need cosine and I need to know sine. I know the cosine, but I also need to do sine. Actually, do we have to find anything? Could we use one of our other equations if you want? One of these other 2? You want to try one of the other ones? Or are you like, I have no idea what's going on right now? Okay, so what we want to do, we want to figure out what cosine of 2 theta is, given that cosine is 3/5. So I'm going to pick this formula because I know what cosine is, and I can just plug it in and I'll be able to find the number. Okay, so cosine of 2 theta, I'm going to use that one because I already know the cosine, is 2 cosine squared theta minus 1. But I'm going to write this instead like cosine theta in parentheses squared. I think that might help. So I just picked the formula that was useful based on what I know. Okay. And so I'm just going to plug in what cosine of theta is. What is cosine of theta? What did they tell me? It's 3 over 5. So 2 times 3/5 squared minus 1.
So right now we using the second formula in green. Right there.
Yeah, I picked the formula in green because they gave me cosine. So I wouldn't even have to draw a triangle or figure out any other trig function. I could just plug that in and substitute it in there. And then let's put in 3/5. And you could plug that in your calculator at this point and then get a fraction. That's fine. I just went through the steps and did it. Okay. On our second one, we need to, we'll write out what the tangent to theta formula is and see what it is we need. There's no cosine that we could plug in, so we're going to have to figure out how to use cosine to find tangent. And we'll need to know what quadrant we're in. Between 90 and 180, that's in quadrant 2.
Could you slow down, please? I need to write this problem. Thank you.
So we're in quadrant 2. That's where sine is positive. So that's good to know. Tangent to theta, that formula from up above, I'm just going to rewrite it. 2 tangent theta over 1 minus tangent squared theta. Well, we need to know what tangent is so we can plug it in here. We know what cosine is. We don't know what tangent is. So remember all the times that we had to figure out from cosine what tangent was or what sine is. What did we always draw to the side when we had one and we needed to find another? We drew a shape. What shape was it?
Triangle.
Triangle. So on these, if you don't know what you need to know, you need to make a triangle and figure out. The cosine is adjacent over a hypotenuse. So that's going to be 8 and 17. And tangent is opposite over adjacent, so we need to figure out what our opposite side is. So 8 squared plus b squared is 17 squared. And we do the Pythagorean theorem, and this side is equal to 15. Okay? So if that side is equal to 15, opposite over adjacent is going to be 15 over 8. So our tangent of theta will be 15 over 8. It was opposite over adjacent. But remember, we're in the second quadrant, so our tangent is actually negative 15 over 8. Now where we see tangent, we just plug in negative 15 over 8.
So why did you make it a negative?
Because it's in, we told us that we're in the second quadrant. So in the second quadrant, the only thing that's positive is sine.
And how do we know we're in a second quadrant? Because of 90? I mean, because of 180?
We're between 90 and 180 is what that says. And between 90 and 180, that's the second quadrant.
Yes, ma'am.
Mm-hmm.
If we have time, can you write down the thing again where it told us which one was positive and which quadrant?
It goes ASTC around the thing. So all sine, tangent, cosine. ASTC.
Okay, thank you.
Mm-hmm.
So ST and AC are right, you know, like they're with each other.
Yeah, those are the positive. Everything's positive here. Sine's positive here. Tangent in this one. Cosine in that one. And right now I'm just putting this in the calculator because I don't want to have to mess with figuring it all out. And I ended up with negative 60 over 11. Did anybody else get that same thing? When you typed it in? Did anybody else type it in?
Since we're in tangent, is it still going to be, is this answer going to pop up on CUDA, or is it going to be decimal form?
This one would be this fraction on this part, yeah. It's just the ones when you end up with square roots on tangent that it makes it look a little weird. Okay. So that is using double angles. When they ask you to evaluate for them, you just look and see what they gave you. See, do you know enough from that? Can you just plug it into the formula? Or do you need to go and make a triangle to find what you need to plug in? Then our very last ones for today are equations where if you see a double angle and you have a mix of like a regular theta and a 2 theta, you can't just get the trig function by itself. We can't solve them when they look like that. We need to have them all in regular theta or all in 2 theta, one of the two. But it's easy for us to switch from a double angle to single by using one of our identities from up above. So this first one is 0. It's negative cosine theta plus 2 cosine theta, or not 2 cosine theta, cosine 2 theta. So I'm going to replace that with an identity from above. Which cosine one do you think we would want to use if our other trig function was cosine theta in the problem? Would we use 1, 2, or 3, do you think? If we have a cosine theta, yeah, we're going to use 3. The reason we're going to use 3 is we don't want to introduce a sine into the problem. Okay, does that make sense? If I've got cosine, just cosine theta, I don't want to put a sine in there because then I'd have to switch the sine to cosine so that I could solve them. So I'm going to pick the one, if you're using cosine 2 theta, that's the same trig function as what I already have in there. So this, I'm going to replace it with 2 cosine squared x minus 1. So that became that. Now I don't have a mix of sine and cosines. I don't have a mix of trig functions. I don't have a mix of regular thetas and 2 thetas. There we go. And now we can just factor that like we did. I think we did this one the other day, actually. I just wrote it in standard form. What multiplies to 1? 1 and 1. To get 2 cosine squared is 2 cosine and cosine. I need to get a negative cosine in the middle. So this 2 needs to be negative and that one needs to be positive. So negative and a plus. Yeah, we did do this exact problem yesterday or 2 days ago. At the end, it got to this point. And you guys can solve from here, right? Yeah, okay. So I'll just leave it like that. Y'all can keep going, get it by itself, find it on the unit circle. And looking at our very last problem, 2 sine theta minus 3 sine 2 theta equals negative 2 sine 2 theta. We've got double angles, so ones with 2 thetas and ones with a regular theta. At least they're all in the same trig function. That's nice. But I see 2 copies where they have double angles, right? You see the negative 3 sine 2 theta and the negative 2 sine 2 theta. I don't want to replace them both. I'm going to move it over to one side, and then I can just substitute one time. Does that make sense? If I add this 3 onto that side, then I'll only have to substitute once. And 3 plus 2 makes 1. I mean 3 minus 2, not 3 plus 2. So that's a more simplified version. I can't solve it the way that it looks right now because I've got a regular theta and a 2 theta. I need them all to be in regular thetas. So I look back up at my identities and see what sine of 2 theta is. And sine of 2 theta is 2 sine theta cosine theta. So I'm going to replace it with that. So this gets changed using my identity. So now we only have thetas. There's no 2 theta in the mix. And these were kind of like in the equation lesson number 2, where you have to move everything over to one side and then we'll factor. So subtracted the 2 sine theta to that side. Are there any squareds in this problem? Nope, there are no squared, so we don't need to do our 2 sets of parentheses. These are just where we look and see is there something in common with both. Is there something in common with both of those terms? What's in both of them? A 2 and also a sine. There's a 2 and a sine in both that we'll pull to the front. That will leave us with cosine theta minus 1. Take that out of there. And we set them both equal to 0 and solve, and y'all can do that on your own.
Okay, so you went from 2 sine 0 2 sine theta cosine theta minus 2 sine theta.
Mm-hmm.
Where the other 2 sine theta go? Because it's only one in this second equation.
I pulled it to the front. It's like if I had 2xy minus 2x. I said, oh, they both have a 2 and an x. So I'm going to bring 2x to the front, and that would leave me with a y minus 1. Because you're distributing it back. If you distribute it, that one would get it, and then this one would also get it.
Oh.
Like for factoring like that. Yeah, you don't write two of them out there when you're factoring it.
Thank you.
And then you would keep going and find these from your unit circle.